Okay, so let me officially start. So I reintroduce myself again. Okay, I'm Teacher Xuan Ming. I'll be conducting a webinar. My other panelists will be Teacher Wendy and Teacher Manpreet. They'll be addressing your questions. Okay, we are going through 3 topics today: electrical system, digestive system, and human transport system. And we only have 1 hour. Okay, so you can imagine it's going to be fast. All right. Of course, you may have a lot of burning questions. Please just throw it in the chat. All right. Teacher Wendy and Teacher Manpreet will address your questions, okay? You can take this time, treat it as a Q&A. You probably have a lot of questions when you're doing revision, right? You can use this time to ask us questions, even while I'm going through this paper, okay? So without further ado, let me start off with electrical system. Please let me know if I'm going too fast, okay? You all can just, it's okay to stop me, I'm okay, man. Okay, so first, I want to start with electrical system with a short definition, just to summarize some of the definitions in electrical system. So as you all know, for electrical system, many times there's a lot of calculation questions, and some people really don't like calculation questions, okay? So when it comes to electrical system, apart from knowing series, parallel, okay, you also need to know certain things like, for example, we have potential difference. I'm pretty sure you all come across this word a lot of times, okay? But the issue is, how many of you all here actually know the definition of all these terms, okay? I still have a few, right? We have current, okay, and we also have resistance. So you'll probably be thinking, Teacher Xuan Ming, resistance is just resistance. Still got definition? Have, of course have, okay? A lot of scientific terms that you all use in secondary school, most of them have definitions, okay? So let me go through the definition. Number 1, potential difference, okay? Potential difference is actually defined as the amount of energy needed to push one charge through a component or a circuit, okay? So in general, you can think of potential difference like like water, right? Water in general, if you leave it be, it will always flow from a higher ground to a lower ground. This is natural. This is the reason why river will flow in the first place, right? How come river will flow from the mountain down and stuff like that? So you can actually think of current. Our current is very similar to a river flowing, okay? So the definition of current is actually the rate of flow of charges in a circuit or a component. So current, just like a river current, okay? In a wire, you can have a lot of charges that is flowing through the wire, and this is what we call current. Of course, when we say that, if let's say there's very high current, it actually means that the rate of flow of charges is very high. There's a lot of charges that is flowing through in 1 second. Usually when we talk about rate, is time-based, right? So we will use 1 second as the benchmark, okay? And then next, resistance. Resistance is actually simply the ratio between the voltage applied to the current flowing through it, okay? So resistance is the ratio between the voltage applied to the ratio between the voltage applied to the current flowing through it. So if I were to write it out in ratio, if I really write it out in ratio, resistance stands for this, okay? Voltage ratio is to current I, okay? So if you all know, right, ratio actually can be expressed as a fraction as well, which is how this formula is being derived. Resistance is equivalent to V over I, voltage over current, okay? And then this formula, now it becomes more and more familiar, right? Some of you may have learned this formula called V equal to IR, okay? Voltage equal to current times resistance. And this is a formula that you will need if you want to solve calculation questions, okay? So V equal to IR, R equal to V over I, they are technically the same thing, okay? So let's look at the first question over here. For question 1, okay, let's read. The resistors are identical but connected in different ways. Arrange the circuits by the order of increasing effective resistance. These questions require students to be able to understand who has the most resistance, who has the least resistance, right? So resistance formula, effective resistance formula, there's a formula which is 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus, depends on how many resistors you have, okay? So this is the general formula to find the total resistance of the circuit. In series, very simple, okay? I want to show you, before we even go and calculate anything, right? This question can be done even without calculation, okay? But however, I want to bring you through this question with calculation to show you actually it's not that difficult. Okay, so first, one thing that will make your life super easy, okay, and this can also be applied to your exams as well, okay? When they say that the resistors are identical, right, and you want to go and calculate them, so what you can do is you can place values to these resistors, okay? And the easiest value to deal with it's 2, okay? So what I'm going to do is I'm going to write 2 ohm here, okay, just to let myself know all the resistors here. The resistance is 2 ohms, okay? 2 ohms, everything is 2 lah, basically. Okay, so for B, very simple, right? Okay, can I just maybe ask a random student, okay? See who's the lucky one. Okay, Jason, okay, I hope you're there. Jason, hope you're following. For circuit B, the resistance, the total resistance of the circuit will simply just be okay. If anybody else know, can just answer. Okay, I will ask B, then I will ask A and stuff like that. B, I start with B because B is the most simple one, right? Okay, 6. Thank you. Okay, Zheng Hao, thank you, Wei Ji. Okay, this is the simple one. So 6 ohms, I will write here 6 ohm. Okay, 6 ohm actually, I think currently from what I see, most probably is the highest. Okay, then we will move to D first. Okay, D, we can actually apply the formula on top. So how would I write it out? I will write 1 over RT is equivalent to half plus half plus half. Okay, and calculator will tell you that this is 3 over 2, right? And what you can do now is you can swap RT over 1 and swap this equal to 2 over 3. And your calculator will let you know that this is 0.67 amperes, rounded off to 2SF. Okay, so this one, 0.67 amperes. Okay, so basically this is how we use this formula to find the effective resistance of the circuit. But the complicated part comes when it's something like A and C, right? So I will leave A to be the last. Okay, let's deal with C first. Okay, can you all just do some quick mental sum if it's okay with you? Okay, can you all calculate what's the effective resistance of this circuit? I hope I can see some answers before I even write finish. Okay, then what I'm going to do, I'm going to swap it around. It will become 4 over 3, okay, which is 1.33 ohm. Okay, so this one has 1.33 ohms. Okay, can you notice how I combine the bottom parallel branch? Because 2 ohms and 2 ohms together is 4 ohms. That's why I wrote here 1 over 4. Why du? Thank you. Okay. Sharp eyes, Hey, Zheng Hao, thanks. Okay, this is not ampere. Okay, change this to ohm. Okay, lastly for A is slightly trickier, right? So because if you imagine the current will be flowing like that, flow through this resistor, okay? And then you will start to split. So meaning to say, if you want to apply this formula here, this formula can only apply to this parallel portion. All right? So 1 over RT equal to half plus half equal to 1. 1 ohm, right? And then 1 ohm. So right now, I can simply replace this. Okay, I'm going to erase this away. And simply just replace this with a resistor that is equivalent to 1 ohm. Okay, so I draw in one resistor. On top here is 1 ohm. And the total resistance is 3 ohms. Okay, so you have your values ready. And because of that, you can now start to rank, right? So just make sure you don't write anything wrongly. Remember, after every time during exam, after you've written your answer, you have to check one time before you leave, okay? There's this example I sometimes will share with my students, okay? So I don't know if this applies to you all, but my parents, right? My mom, she loves to cook, right? Okay, so she's actually very concerned every time when I say I want to cook, okay? Because she always has a habit, right? When she's cooking something, she turn on the fire, okay? Then after she finished cooking, right? Even though she knew that she turned off the fire already, but after when she leave the kitchen, she always turn back to take a look, just to double confirm that the fire is really off, okay? I don't know if you'll see the link here, but what I'm trying to say here is do not just simply rush off to the next question after you have written down your answers, especially for MCQ, okay? After you written down, spend some effort as well just to verify that, okay, I think this answer is correct, okay? I am satisfied, then you move on, okay? So in this case, the answer here will simply be smallest to greatest, because increasing, right? So I'll start off with D, then I'll go with C, and then I'll go with A, then I'll go with B. Okay? So D, C, A, B. Okay, next. Okay, next question. The heater is connected to a 12-volt battery, okay? So there's a 12 volts given to you here. The fan has a potential difference of 6 volts. So what I will do here is I'll go and write 6 volts here to tell myself that, okay, there's 6 volts of voltage going through this fan. And if you remember your properties of a parallel circuit, right? If this branch over here has 6 volts of energy pushing the charges through it, over here, it shall be the same as well. Meaning to say, the bulb will also receive 6 volts over here. Okay? However, the amount of voltage that the battery supply in total is 12 volts. And currently, only 6 volts is being used. Meaning to say, our heater friend here, right? He is using the remaining 6 volts from the battery. Okay? So this is basically 6 volts plus 6 volts will add up to 12 volts. Okay? And the 12 volts over here, because it's the battery, right? We say that this is the EMF of the battery. Okay, if you don't know what's the meaning of EMF, it's fine. Okay, but for those people who know, EMF stands for electromotive force. Basically, the voltage of the components add together must give you the battery's voltage. Right, so now we can move on because we have certain values now. Okay, there has a current 1A going through the fan. 1 amperes of current is flowing through the fan. 2 amperes of current is flowing through the bulb. Okay, there's a trick here that I'm going to teach you guys to ensure you do not make any careless mistake for calculation question. So this is what I'll teach my students to do. So you must understand that this V equal to IR formula, right, can be applied to 2 things. Okay, so number 1, V equal to IR, number 1, it can be applied to the circuit, the entire circuit. Number 2, okay, it can be applied to a single component. Okay, so when you're using V equal to IR, you have to be very clear. Are you calculating the values? Is it related to component or is it related to the circuit? So to reduce errors, right, this is what I teach my students to do. For the bulb, Okay, since they are asking for the bulb, right? So what I'll do is I'll write bulb here, and I'll draw an underline, and I'll write VIR. Of course, the prerequisite here is that you all need to understand this formula, VIR. Okay, in fact, just go and memorize this formula. Okay, VIR. So now I go and look at my bulb. What's the voltage that is supplied to the what's the voltage of the bulb, which is 6 volts? What's the current that's flowing through the bulb, which is 2 amperes? And therefore, I will know that my resistance of the bulb will be 3 ohms. Okay, so since it's just 1 mark, okay, I will just put the resistance 3 ohm over here. Okay, then now I'll move on to the next part 2. Okay, calculate the potential difference across the heater. Oh, we already got the answer already. Okay, but I want you all to show proper working, right? So first, I'm going to let you all know that EMF of the battery equal to sum of V of all components. Okay, and because EMF here is 12 volts, and I know that I have 6 volts. This is 6 volts belongs to who? 6 volts belongs to the parallel circuit. I'm writing more than you all need. Okay, it's just to make you all understand. Okay, parallel circuit. And then plus question mark volts, right? From the heater. This is the heater. Okay, therefore, you can just simply use 12 volts minus 6 volts will give you 6 volts. So the potential difference going across the heater will be 6 volts here. Okay, so now calculate resistance. Okay, when you ask you to calculate anything related to V equal to IR, right? Always you can use this heater, then you write down VIR. Okay, then you ask yourself, okay, you know that the voltage for the heater is 6 volts. You write 6 volts here. Okay, do you know the current? So now the current, take a look. Okay, I'm going to use blue color to represent this. Okay, imagine there is one car going through this path. Okay, there's one car going through this path. There is 2 cars going through this path. Yeah, 2 cars. Why is it not showing? Okay, there's 2 cars going through this path. So when they converge, right? Okay, when they converge, by right now, there will be 3 amperes going through the heater. Okay, because the current will converge and then they will combine. So you can imagine, like I said, current is really very similar to river, guys. Okay, imagine you have many small streams coming together, forming the river. Okay, so they will always add up and make the river current even larger. Okay, so small streams have their own current. When they merge, they will form a greater current. Okay, so this is how you should understand current. So in this case, we can establish that, the heater has 3 amperes flowing through it, right? So I'm going to write the current here, I'm going to write 3A, and therefore, I will know that my resistance here is 2 ohms. Okay, so my answer is 2. Okay, moving on to the next one. Okay, next is electrical consumption. So sometimes we are concerned about how much electricity you all consume, right? Actually, you are not very concerned because you all don't pay the electricity bills, right? Okay, but some parents, they will be very particular about all these things. Turn off the switch before you leave your house. Switch off the light before you leave the room. Stuff like that. Okay, anyway, take note. Over here, energy consumption, right? The units for energy consumption is always kilowatts per hour. Okay, kWh. But you'll notice that over here, my question purposely give you power only. Okay, and the power, the units is W. So you have to change power which is in watts, in W, you have to change it to kW when you're doing a calculation. Okay, so in this case, 2000 over here, I'm going to change to 2000 here is 2k watts. Television will be 0.15k watts. Okay, so using the first one as the example, what you simply need to do is you just need to use power times how many hours you are using it. Okay, so you use 2 times 8. Your answer here will be 16 kWh. Okay, next. 0.15 times how many hours will give you 0.225. You simply can just use your calculator. Okay, you will get 1.5 hour. Same for computer. You use 0.375 divided by 1.5. You will find out that the power will be 0.25 kW. Okay, just sharing. Power in general, right, is equal to energy over time. And power, the units is W, right? The units for energy, in Sec 2, you all have learned energy is joules. Time will be seconds. Okay, so it's basically how much energy per second. So that's power for you, okay? Okay, part 2 over here, the cost of 1 kWh. Okay, so this is the cost of 1 unit, 1 unit of electrical consumption, and that costs 30 cents, right? Calculate the total cost of using electricity in 1 week. So these are the appliances that I'm using: aircon, TV, computer. This is the energy I'm using per day. Okay, so what you need to do is you go and find 1 day lah. 1 day, 16. Sorry. Okay, so this is basically 1 day. Okay, you'll be able to find the value here, which is, yeah, 16 plus 0.225 plus 0.375, you get 16.6. Okay, and then you go and find 1 week, which is 7 days. Okay, which is 16.6 kWh times 7 days. Which gives you 16.6 times 7. Sorry, it gives you 116.2. Okay, and then the cost, just need to multiply it with 30 cents. Okay, so you just times 30 cents, 116.2 times 0.3. You should get $34.86. Okay, before I go to part 3, I pretty sure I know that everyone here knows what's a fuse, right? Okay, the fuse is considered a safety feature, right? However, I do not know, I think many students don't understand the difference between a fuse and a circuit breaker. Circuit breaker is also considered a safety feature in electricity as well, okay? But I think most students don't know the difference, okay? You all can prove me wrong, okay? If you all know the difference, can you all please type in the chat, what do you all think is the difference between a fuse and a circuit breaker? Similarity, don't need to say that, okay? Their idea is to cut off electricity, right? But what's the difference? Okay, can I see some answers in the chat? Let's see. Okay, so I received some answers already. So there are some misconceptions. Okay, but there are also some things that you all say that is correct. Okay, so some students mentioned that. Okay, sorry. Some students mentioned that the circuit breaker is when the fuse gets too hot. Is that correct or is that wrong? It's half correct. Both the circuit breaker and the fuse, right, they will actually cut off electricity when current is too high. Okay, because when current is too high, it's dangerous. People may get electric shock. Because it will heat up and then it will cause electrical fires. So you have to cut off the current. But the difference is this. If you remember, like what Zheng Hao mentioned, circuit breaker, there's a switch whereby you can flip the switch up, flip the switch down, and stuff like that. Okay, so meaning to say, the key difference here is this: circuit breaker can reset. The word you all should be using is the word reset. Okay, the fuse has to be replaced after it melts. However, the circuit breaker can be reset and used again. Okay, so that's the main difference. Okay, but thanks for putting in your answers. Okay, I hope you all learn this difference. Okay, anyway, explain the use of a fuse. Okay, so when this current is too high, it will start to melt. And this action of melting breaks the circuit, open the circuit, preventing overheating, leading to electrical fires. And that's not all. There's a second portion to this answer over here because they ask how it should be connected in the plug. Okay, if you remember in the plug, right, if it's a 3-pin plug, it means that there's 3 kinds of wire. We have the live wire, the neutral wire, and the earth wire. Okay, how come my Nintendo Switch at home only got 2-pin plug? Okay, reason very simple. None of the casing is actually made of metal. So there is no need for earth wire to direct electricity to the earth. Because even if I were to touch the casing of the Nintendo Switch, I wouldn't get electrocuted. Okay, so that's why certain appliances you'll realize there's only 2-pin plugs. But however, if things like a washing machine, your refrigerator, your oven, okay, they have metal casings, metal outer casings, right? So those kind of things can conduct electricity. You definitely need to have a 3-pin plug for that. Okay, anyway, the how it should be connected is the fuse. The fuse should be connected to the live wire in the plug. Okay, next. Should be okay. Next, the fuse should be connected to the live wire. Okay, next. A lamp is connected to a 240 volt supply, which converts energy at the rate of 100 watts. Okay, actually it makes sense, right? You see, a lamp, what does it do? What kinds of energy does it convert? It converts your electrical energy to light energy and heat energy, correct? So that's why they write at the rate of 100 watts. Remember just now I told you that power is equal to energy over time. Okay, so in this case, we have 100 watts. What does that mean? It means that 100 joules of energy is converted per second. That's the idea. Okay, how much energy is being converted in 1 hour then, right? So if, let's say, in 1 second, we know that it's 100 joules of energy being converted, we simply need to go and find in 1 hour how much energy is being converted. Okay, you can use, you can use power equal to energy over time, right? And then you manipulate this formula to make it such that energy is the subject right now. So E equal to power times time. So the power here is 100 watts, okay, times 60 minutes times 60 seconds, okay, and that will give you 360,123 joules. Okay, this is the total amount of energy being converted in 1 second. Okay, for 3B, right, only a handful of you here may be tested on this question, okay? So if you have not seen this formula before, okay, you can just listen to my explanation, okay, but there's no need for you to go and learn if let's say your school doesn't teach this yet, okay? I equal to QT over here refers to current equal to amount of charge flowing in 1 second, okay? So just now I mentioned to you the definition of current is the rate of flow of charges. Simply put, it means how much charge is flowing through the circuit in 1 second. Okay, so it can be represented in a formula as well, I equal to QT. Okay, so in this case, we simply just need to go and put in the formula. 1500C charge, okay, this is under Q. Okay, 1 hour is the time. Okay, we need to change this to seconds. Okay, take note, we need to change this to seconds. So you were to calculate current, right? Meaning to say I will be our subject. We put down the formula I equal to QT. Q is 1500 charge. And the number of seconds in 1 hour is 3,600 seconds. And therefore, you will be able to get 0.42 amperes. Okay, I repeat once again, not everybody will be tested on this question. So you can choose to ignore this question if there's no need, right? Okay, so we just need to focus on this value over here, okay, because this value will be needed for part C. Okay, calculate resistance of the lamp. Okay, so we go straight into doing what I teach you earlier. Write lamp, write VIR. Okay, go and find out what's the V. If you got read the question carefully at the top, they already say the lamp has 240 volts. Okay, so I'm going to put down 240 volts here. And I've just found out that the current is 0.42. Okay, so I'm going to put down 0.42 and I can find my resistance simply by using 240 R equal to 240 divided by 0.42. Okay, the resistance will be 576 ohms. Okay, 576. Okay, next, another electrical consumption questions, okay, just for you to practice. Okay, the cost is 27 cents per 1 unit of electrical consumption. Okay, what is the cost of using the lamp for 0.5 days? Okay, so you want to find how much energy is being used, right? First, you go and use energy equal to power times time. Okay, where did I get this formula from? Once again, is from this formula, energy over time. Okay, so how much energy used is equal to power times time. So I'm going to convert over here, this power, take note, okay, put a bracket here. It must be in kilowatts. Okay, and the time here have to be in hours. Okay, This is the reason why my electrical consumption, the units is kWh. Does it make sense? kWh equal to kW times h. Huh? So what's my power in kW? At the very start, we have the value 100 watts, but it is not in kilowatts. So we have to go and change it, okay? Change it to 0.1. 0.1 kilowatt times half a day got how many hours? Everybody should know, okay? 12 hours. So your energy consumption is 1.2 kWh. Haven't end yet. We have not times the amount of money. So you find the cost, you just use 1.2 times 0.27 dollars. Okay, your answer will be 32 cents. Okay, so just ensure that if all these are being tested in your exam, right, please make sure you are very familiar with all these formulas. Make sure you are familiar when to use kilowatts, when to use watts, okay? If you don't know, please ask this question. We have teachers here to teach you when to use, when not to use, okay? Kilowatts and watts, if you never do the conversion, your answer will be very different. Okay, next, we go to digestive system, okay? For digestive system, first, most important thing over here is you all need to understand what is an enzyme, right? And then what are some examples of enzyme and what the enzyme can do, correct? So first, okay, there's a few key things I want you all to take note, okay? Number one, enzymes are enzymes will denature under high temperature, okay, or unfavorable pH conditions. So your enzymes are very sensitive workers, okay? If you give them too much heat, if you never give them the right pH, okay, they will not want to work for you. Or rather, they will become very not motivated, and then your digestion will break down, will become very slow. Okay, take note, the word here we use is denature. Don't go and say, oh, enzymes will die. Please don't do that, okay? Don't use the word die. We don't really use the word die in science, okay? It's not auspicious. Please don't use the word die. Okay, anyway, another thing about enzyme is that it can be reused, okay? This is actually something that a lot of students don't know. Some people think that, oh, your enzyme react with my protease react with protein to form amino acids. Hey, no, not react, okay? They are not involved in the reaction, okay? They facilitate only, okay? So they can be reused a lot of times one. So meaning to say, the ratio of enzyme to the number of, the ratio of protease to the number of protein don't have to be 1:1. I can have 1 protease is to 100 proteins also can, okay? Because these protease can be reused over and over again. Okay, next. Okay, quick one. Okay, let's not waste time. Mouth got what enzyme? Okay, I'm looking at the chat. You all just type down. Mouth got what enzyme? Okay, I have people answering salivary amylase, which is very good. Okay, some students learn it as carbohydrates. Okay, that's also fine. Okay, but salivary amylase is the specific term. Okay, salivary amylase, and this salivary amylase here. Okay, so your mouth in charge of producing salivary amylase that breaks down starch into maltose. Okay, maltose here. If like I said, some schools they don't teach maltose also, they use sugar. So please, like I said, there's many variations of things that different schools teach. So if you have any questions, please don't keep it to yourself and just ask. Okay, there's a reason why I plant so many teacher assistance here, okay, is to answer all your doubts. Okay, anyway, then let's move on. Next, we have the stomach. Stomach, we have only got one thing, right? We have our proteins. Okay, stomach digest proteins. Okay, digest proteins to amino acids. And who is the one facilitating this? Is our protease. Next, we have our pancreas as well. Okay, pancreas also important. Pancreas over here, it can break down starch. Okay, it can break down fats. It can break down proteins. And our starch over here will become what? Will become our maltose. Okay, done by who? Done by our pancreatic. In this case, it's not salivary anymore. We say pancreatic amylase. Okay, and next, we have our fats broken down into what? Fatty acid and glycerol. Facilitated by who? Pancreatic lipase. Next, we have proteins. Proteins over here, you just need to, it's the same amino acids facilitated by protease. Okay, so if let's say at the back of your head, all these things can just come into your mind. It means that you are super familiar with this topic. And by right, you should, right? No choice. If you want to take bio, it's like that. Bio, there's a lot of things to memorize. But if you are good at memorizing, then this shouldn't be an issue to you, okay? And lastly, I have small intestine. Okay, small intestine, almost everything is the same except for a few things, okay? So I'm lazy, I'm going to copy paste. So first, for small intestine over here, okay, I'm breaking down my maltose into glucose. Okay, so this is a bit different. And over here is intestinal amylase. Okay, why? Because this amylase comes from the small intestine. It does not come from the pancreas. Okay, next, your fats is the same, okay? Intestinal lipase, and then there's also protease as well, okay? Intestinal protease. Okay, so in general, these are the things that you have to go and memorize, okay? There's another part, which is your liver. Okay, I know I'm going through a lot, okay? If you cannot find enough time to copy all this, don't need to worry. I will send you all the annotated copy, okay? So I rather you all just listen and ask questions here. Copying, you can copy anytime, okay? Important thing is ask questions, okay? Liver, what they produce this thing called bile, right? Bile, what does bile do? Okay, it carries out emulsification. Then you'll be asking, this word very familiar. What's emulsification? Okay, so emulsification, basically what they do is to break down large fat molecules into tiny fat droplets. Why? Why so mafan? Why must break down the large fat molecules into tiny water droplets? Okay, reason being, by right, who need to manhandle the fats? Is the lipase, right? Okay, so we break down these large fat molecules into tiny fat droplets so that the lipase can break down faster, okay? To increase okay, to break down lipase, to break down fats at a faster rate. How come? Because when you have many fat droplets, tiny one, it actually increases the surface area to volume ratio. This phrase over here is an important phrase. Many of you here, if you are still using surface area only, right? Okay, it's considered low level. Please go and reflect. Right now, we should be using surface area to volume ratio. Okay. Okay, finally, I can start the question. Okay, which statement below is true? Protease is produced in X. Is that true? Okay. protease is produced in X. Hang on. Okay, I made some mistakes here because I copy paste. Okay, please change this to maltase. Okay, change that to maltase. Okay, next. Sorry, Teacher Manpreet, can you help me double confirm small intestines will have protease as well? Thanks. Okay, so this one, let us double confirm. Okay, protease produce, when they say produce, means that small intestine is the one that produce it. Okay, so this one, wait a while. We look at 2 and 3 first. pH environment in U is acidic.
Yes, they do.
Okay, so this is confirmed. Okay, protease is produced in X, small intestine got protease, so we take this. pH environment in U is acidic. Your mouth over here, your saliva is not considered acidic. In fact, it is generally neutral. Okay, the acidic one is your stomach, so this is out. Next, lipase is produced in W and stored in V. Lipase is produced in W and stored in V. Hang on. Wait, I think, wait, this is, sorry, guys, there's a typo here. Please change this to bow. Okay, this is bow. Please change this to bow. It's not lipase. Okay, bow is produced in W because W over here is the liver. Okay, this is the liver and stored in V. V is a gallbladder. Okay, so bile is indeed produced in the liver and stored in the gallbladder before they are channeled into the small intestine. In this case, 1 and 3 is correct. Okay, answer is A. Okay, next question 3. Okay, explain the function of villi and the microvilli. Okay, the microvilli is basically all these small dots that I draw here. These are the microvilli. This entire thing is the villi. Describe. Sorry, you have to explain the function. Why do we have a lot of these things inside our small intestine, right? It is related to our surface area to volume ratio. Okay, this word must appear in your answer. Okay. Okay, so 2 marks. Okay, you need to have 2 points. Okay, the day, you can just coin them as day. They increase the surface area to volume ratio. Okay, those people who have attended my webinar before, you will notice that I actually teach students to use the ICE technique. Okay, in secondary school, ICE technique is one answering technique that can be applied to explanation questions. Okay, with I being identify answer. Okay, C being compare evidence. Okay, and E being the effect of evidence. Okay, why is the answering technique needed? Okay, because you can just ask, every student, you can just ask yourself, every time when it comes to explanation questions, how many of you have the trouble of thinking how to start, how to write, what to write, exactly how to write? Okay, and most of the time, students may face mind block. Okay, so trying to follow a structure, a consistent structure, a proper answering technique will actually help you kickstart you writing the answers. Okay, so over here, use ICE. In this case, they are just asking to explain. There is no need to have the I. So we will just be using our C and E over here. Okay, so the first sentence that I wrote basically is the C portion. Evidence. Compare the evidence. Okay, because of the VLE, they increase the surface area to volume ratio in contact with the digested food. Okay, and then now I want to bring in the effect of the evidence. Effect of the evidence simply means so what? So what? They increase the surface area to volume ratio. So what? Okay, so you tell me that because of the increase in surface area to volume ratio, the absorption of digested food into the blood vessels increases. Okay, effect of the evidence. Absorption of the digested food into the blood vessels increases. Okay, like I said, don't worry that you don't have enough time to copy. Later, once I send you this annotated copy, you have all the time in the world to go and copy. Okay, I won't stop you. Next, describe the advantage of the villus wall being only one cell thick. Okay, so this over here, one cell thick, if you can link this to another topic, you realize that that topic also got this phrase called one cell thick, okay, which is our capillary, right? Capillary, the reason why it is one cell thick is to ensure faster diffusion for the exchange of materials, exchange of dissolved substances. Okay, so over here, same thing. I want the digested food to be absorbed into the bloodstream very fast. Okay, so it has to be one cell thick. How do you describe the advantage? You just need to say that digested food can diffuse quickly into the bloodstream. As simple as that. Okay. Okay, next. Okay, got this disorder called cystic fibrosis. Okay, it's a genetic disorder. What it does is it builds up thick, sticky mucus. And this thick, sticky mucus blocks the bile duct and the pancreatic duct. Explain and describe why a person diagnosed with this condition will find it hard to gain weight despite having a healthy diet. Okay, so you must understand what when you block the bile duct, what are you preventing from going somewhere? When you block the pancreatic duct, what are you preventing from to go somewhere? Where? What are you preventing here? Okay, so you need to explain them separately. Okay, this is a 4-mark question. Most likely, you have to talk about bile duct and the pancreatic duct separately. Okay, so I'm gonna start off with the bile duct first. Okay, so the blockage in the bile duct. Okay, blockage in the bile duct. Okay, once again, this is evidence. Okay, evidence. What does a blockage prevent? Okay, and then you have to reference from being released into where? Okay, so if you don't have bile entering the small intestine, there's a few things that will happen. So you have to tell me what's the effect if there's no bile being released in the small intestine. So number one, okay, So if your fats cannot be emulsified, meaning to say there is no more tiny fat droplets. Okay, and because of that, your lipase will not be able to break down large fat molecules effectively. Okay, then now I'm going to move to the pancreatic duct. Okay, same thing. I'm going to put the C first, then I'm going to put the E. Blockage of, same thing, I'm going to use the same format. Blockage of the pancreatic duct prevents what? This time around, there's a lot of things they prevent, you know not? They prevent, number one, prevents your amylase, your lipase, and protease. And then referencing release where? Into the small intestine. So what? Okay. Thus, the digestion of what? Amylase breaks down, in general, what does it break down? The digestion of carbohydrate or starch, both is fine. Okay, the digestion of carbohydrates, proteins, and fats will become slower. Okay, it'll be good to have a concluding statement here. Okay, so I want to add in a concluding statement to link back to the question of how come this person find it hard to have a healthy diet. Okay, so the patient will not be able to have enough digested food to be absorbed into his bloodstream. Okay, so number one, your lipase digests fats very slowly. Number two, you don't have all the pancreatic digestive juices. Your carbohydrate, your proteins, your fats digestion all become very slow. The patient will find that more often than not, his digested food not enough. The small intestine cannot. The bloodstream will not receive enough digested food. So no matter what he do, he realized no matter what he eats, he also cannot gain weight effectively. Okay, so this is the idea. Okay, so quickly let me go to the last part. So for the last part, right, because of lack of time, I will not go through any questions, but this is a very condensed and summarized notes prepared by me to help you all revise this part. There's a few things I want you to take note here, so I hope you all can pay attention. There are quite a few misconceptions here. A lot of students think that artery, right, definitely have to be O2 rich. Okay, you can ask yourself over here, anybody keep thinking arteries is O2 rich, veins is CO2 rich. Okay, if you have this idea, I just let you know first, this is a misconception. In primary school, it may be valid, but in secondary school, sorry, cannot. Okay, the actual definition of artery, it must mean that it carries blood away from the heart. Okay, I'm going to highlight here, away from the heart. And for the veins, right, it carries blood back to the heart. Okay, I'm going to highlight this, back to the heart, right? You need to go and understand the structure of the arteries and veins, okay? If you don't understand, please ask. Over here, there's some simple explanation provided. Okay, the arteries have a thick muscular and elastic wall. You can see so thick, right? And then you can realize that the lumen is very narrow, okay? Narrow lumen. If you don't know what's the lumen, lumen basically means the gap over here, the cross-sectional area here. This is the lumen, narrow lumen, okay? Narrow lumen, what it does, it increase resistance, okay? To increase blood pressure. You must understand, your arteries are bringing blood away from the heart. they are going to travel very, very, very long distances. They have to go through your arms, go through your legs, go through your stomach, go through everywhere. They have to travel very far places. So they need to be able to withstand a lot of blood pressure so that they can travel a further distance. Okay. The veins in general don't have to, because by the time the blood reach the veins, right, the blood flow will have very low pressure. So they don't need to have thick walls to withstand the pressure anymore. And because of that, in veins, because it has low pressure, right, you need to have valves. Okay, there's a typo here. This is valves. Okay, valves very important. Valves, what it does is prevent backflow. Okay, prevent backflow. Your blood's supposed to flow in only one direction. If there's backflow, something is wrong. Okay. Lastly, we have our third one, which is capillaries. Capillaries, everything is written here. Okay. There's a few things, two main functions over here. One, cell thick for shorter distance of diffusion, which also in terms, it means faster diffusion. Secondly, extensive branching. Okay. Some schools don't use the word branching. They use the word network. Network also fine. Because if you have excessive network, it means that you have increased surface area for exchange. Okay, then you will exchange substances at a faster rate. Next, the plasma, red blood cell, white blood cell, platelets, what are their functions and what are they made of is also written here. You can go and read it yourself. Okay, the next part is the one I want to bring your attention to. All right. So over here, I'm going to teach you all some tricks to quickly remember how to draw the 4 heart chambers. Your right atrium, left atrium, right ventricle, left ventricle. Okay, so the easiest way to remember how to draw this in the correct order and position is you have to understand that you are looking straight at this heart and it has to be laterally inverted. Okay, so meaning to say the right side of this heart have to be your left side of your actual heart. Okay, and then the next thing is this. How do I always know that on top is atrium, below is ventricle? I go by alphabetical order, right? So A always comes first and then V is the last. So V is at the bottom, okay? And this will also give you a very clear indication of how blood is flowing in these chambers, okay? So basically, in this chamber, the blood will be flowing like this, okay? The blood will be flowing like this. Okay? Okay, I want you all to, in your notes, right? I want you all to continue drawing lines, okay? Please, first, can you all write lungs, big here, lungs. Over here, write body. Then we have to go and connect the arrows, okay? So the lungs give O2 rich blood, okay? Over here, I'll write O2 rich. Next, your right ventricle, pulmonary artery, go to the lungs. This one is CO2 rich. This one connect down. This one also CO2 rich. This one connect down. This one is O2 rich. Okay, so there are a few patterns you can see. Your blood will always be leaving the ventricles. You can see your blood leaves the left ventricle to go to the body. Your blood leave the right ventricle to go to the lungs. Okay, so ventricle is always the endpoint, which is why I say this arrow and learning this alphabetical order thing really helps a lot. Number one, you not only remember the position of the atrium and the ventricle, you also know how the blood flows. inside the chambers itself. Okay, and take note, why we have the word pulmonary. Okay, as long as you have the word pulmonary, right, it just means, okay, pulmonary basically means connected to the lungs. Okay, your right ventricle is connected to the lungs. That's why they have the word pulmonary there. The reason why it's called artery, okay, go back to the definition. Why is it called artery? Artery is when blood is moving away from the heart. Regardless of whether there's a lot of oxygen or carbon dioxide, does not matter. Okay, as long as it's going away from the heart, it's called artery. Okay, even though this is CO2 rich, it's still called artery. Okay, pulmonary means connected to the lungs. Okay. Over here, the characteristics of the heart, you can go and read it up yourself. Okay,